Assalamu alaikum. Now we are in the part 2, that is the final part, the writing part of the Grade 10 Elite. And here the question number 16 to question number 20 are included. It must be in writing in detail. Before I start with this question, I just want to apologize that it's been a bit delayed when I'm finishing this writing part for the Grade 10 Elite. I'm sorry because I was planning to finish it earlier, but there were a set of unfortunate circumstances where my laptop had some issues and that had to be fixed and it took a lot of my time and it got delayed. And my car, for example, yesterday broke down in the middle of the road and it's holidays now, so it was very hard to fix it. I just left it there and came back, and that's why I've been doing it late nights. And but anyways, I've tried to do how much I can, and whatever is there, please do go through them. And now I'll try to finish it before the exam by today in few hours. But try to revise how much you can, and the presentation is already available. You can click on the link in the description and get the presentation. Now the 16th question here is to determine the number and type of roots of quadratic equations. Here you need to know about the discriminant. We know quadratic equation, quadratic formula. Don't want the entire formula. The discriminant over here, which has been mentioned, is just b squared minus 4ac. What is this ABC? Here, this is the quadratic equation. Whatever is before x squared is a, whatever is before x is b, and lastly we have the entire term to be c, the constant part. Now if we have these values, we can find the discriminant. Let's just substitute this, okay, over here. That is 1, minus 3 and minus 40. Let me substitute it. B is minus 3 the whole square minus, what is 4? 4 is constant, sorry, what is A? A is 1 and C is minus 40. Let me solve it up. It will be 9 minus 4 times 4 is 16. It will be plus, minus and minus will be plus 160. And the answer over here will be 169. Now this is the part in the, the formula, the quadratic formula, inside the square root, okay? 169. Now this one over here is a perfect square. In the sense, you'll get plus or minus 13. If it's a perfect square, wait 1 minute before we go in detail. Over here they're just asking us to differentiate between one another. So you do not need to know other details, but only if you find this, it's enough. Okay, I'll tell you why. This is the answer, 169. Now, same way you need to find the others, by the formula, and you must see what is happening. Same thing, A, B, C, and find out what are the answers. We will just look into the answers now, and I'll tell you, but I will tell the other part about the discriminant in a while. For now, we will just look. This is 169. Fine. This is what, 289. The another answer was 196, and the last answer over here we got minus 20, the last one. All the three over here are having positive values and one over here is having negative value. This means there is certain rules. Now I will tell you about the discriminant. When discriminant, that is b squared minus 4ac, is less than 0, you will have imaginary roots. Two complex roots or imagined roots. You will have two imaginary, okay, imaginary roots. Here b squared minus 4ac, when it's equal to 0, you will have only one root, one real root, which will be a rational number. And when it's b squared minus 4ac is greater than 0, you will have two real roots. These are the circumstances. You must remember this. Two imagined roots. Now over here, since we have minus, less than 0 is minus, we have imaginary or complex roots is the more appropriate term, complex, okay? Here we will have complex root, whereas over here we will have two real root, two real root, two real root. I hope this much is clear. Now then, what next? The next thing is, oh, okay, this is it. Over here you can just tell this is it. But you need to know one more thing about this, because for the next problems, this is very important. When it is greater than 0, there are two real roots, but there are certain circumstances. In the sense, when it is a perfect number, discriminant is always under a square root. So if it's a perfect number like 4, Or 16, square root 16 is plus or minus 4. Or say we got 169, this is root 169 is 13. These are all perfect numbers, right? Perfect squares. So when such numbers come, you will have, like in the graph, right? You will have roots which are rational. Answers of these solutions will be rational in the sense over here it can be -1 or 3.5 or something like that, which can be written in fraction. Whereas if it is not a rational number, say 8, if you put square root 8, you will get some other, it's not a perfect square. You won't get a number, you will get something else, like a decimal. So such things will have irrational numbers like 1.7532, like it just keeps on going, it doesn't stop, such numbers. So you need to understand this, this definitions or this divisions. So now with that knowledge, we will solve the other problems. The first one is very simple. Just find all the discriminant. Here we got negative, so this is error. I mean, this is the odd person out. So you will have two complex root. That's the thing, okay? Other three equations have two rational roots. Why? Because all we're having perfect squares. That's the reason. Now then, the next one over here is about finding the error. Let's look at this problem. Here you can see Tama is doing certain calculation and Jonathan is doing certain calculation. Oh no, sorry, they're doing the same calculations, okay? They're solving this. They're finding the discriminant. No, they're doing the discriminant and trying to find what exactly is the solution. Now over here you can see Tama has got -57, so negative means no real solution. Yes, that's... And over here, Jonathan, see, both are doing the same problem. They're getting different answers. I'm not sure which is correct. We will do it in a while. Now, since the discriminant is positive, here there are two real numbers. Yes, this is also correct. But two real numbers is correct. But who has done an error? Let us solve it. The A value is 3, B value is -5, and C value over here is equal to, it will come inside. So what you have to do is 3x square minus 5x minus 7 is equal to 0. B square minus 4ac is the discriminant. You will have -5 the whole square minus 4. A is 3 and 7 is -7. That's it. Here it will be 25 minus 4 times 3 will be, wait, let's do like this. 7 times 3 is 21. 21 over here it will be 80, 84. But this will be plus because minus and minus. Now add them up. It will be 100, 100 and 509. Now this person, Jonathan, is the person who got it right. Okay, so that's the answer, and it's only two real roots. Now why this person Tama got wrong? Here you should take -7, whereas this girl did not take -7, she took plus, and that's the error. I hope this is clear. This is the answer, and so who is correct? Jonathan is correct. Now what about these problems? Here you have to reason them. Determine whether each statement is sometimes, always or never true. Explain your reasoning. In a quadratic equation written in standard form, if A and C have different signs, then the solution will be real. Yes, absolutely, right? Now what is this exactly? Let's write the discriminant formula. B square minus 4ac. If A and C are having different sign, let it be any numbers. Okay, let's take 2 and 3. That's fine. But I have -2 or +3, or if it's +2, it will be -3. The signs are different. So here when you solve, what happens? -4 into 2 -3. It will be plus. Answer will be plus. Or if this is minus, then this will be plus. Then again it will be plus. Only if both are minus or both are plus, then it will be negative. So they have told if the opposite signs, different signs, then the solution will be real. Yes, absolutely, it will be real. Okay, it's always true. Now, if the discriminant of a quadratic equation is greater than 1, two roots are real and irrational. Now, this is, okay, not correct. If the b square minus 4ac is greater than 1 or greater than 0, yes, it will be two real roots. Real roots is correct. But whether it will be always irrational, we can't say, because if it's a perfect square, the discriminant over here, whatever is this value, is a perfect square. Like 9, 16, 25, 36, 49. If these are the numbers, then it will be rational numbers. Whereas only if they are not these numbers, if it is 8, 11, 12, 4, 15 or like this, then they are irrational. So it's sometimes true, sometimes not true. Okay, sometimes is correct. Sometimes. That's the thing. And over here, sketch the corresponding graph and state the number and type of roots for each of the following. Now over here, when these queries, oh, look at this, they have given the discriminant is equal to 0. Now let me just draw it. Whenever there is 0, there is only one real root. This is a rule in discriminants. So if it's one real root, when you solve the quadratic equation and calculate, you can check that it will be only x is equal to like 1 or 2, only one answer. That means it will be x minus 1 the whole square. Such problems. Here what happens is the graph will only touch the axis at one point, one solution, and then goes. Don't think y-axis is a solution. This is not a solution. Only at x-axis, x-intercept is the solution, zeros. Now when it touches only one point, it's only one solution. This is the graph. Okay. So the graph, however, over here now 4 but only 1 point. That's the answer. It touches only once. That's the concept. Now, what about a quadratic function in which f of x never equals 0? Okay, a quadratic function in which f of x, the y value is never equal to 0. What exactly does that mean? Let's understand. Doesn't matter what you put now for a f of x equals, say, x squared plus 2x plus 1. Okay? Like this. This is a random one. Yeah, this can be said whatever, doesn't matter. See, now mine, I'm not sure whether this is a proper example, but just to make you understand, whatever x value you put over here, whatever x value, this value will never be equal to 0. It cannot be. It can be any positive number, any negative number, but it will never be 0. In the sense, the graph can never touch this 0. If this is never equal to 0, it never touches this graph like this. This cannot happen. This is wrong, right? So the graph can be either like this or like this, something like that. Okay, it can't be like this. It should be only going downwards or going upwards. In such cases, you will have imaginary roots. It's not real roots, it's complex roots. So the graph will be something like that. See, it will never ever touch. So what is the discriminant value? It will always be less than 0. Because f of x is never equal to 0, so it should not touch this line. Y cannot be this, y cannot be at 0. That's it. Now, quadratic function in which f of a is equal to 0 and f of b is equal to 0 and a is not equal to b. Now, it depends what you are substituted, but these two values are different, but both answers are, when you substitute these both, they are equal to 0. In such case, what happens is, you are getting a solution over here. Now, what it means is, let me just draw the graph. Let it be, this is the graph. F of a, like a, I'll take it to be minus 3. At minus 3, you are having the solution. Let me take b as 4. At b, you are having a solution. Are these two equal? No, they are not equal. You're having two separate solutions, isn't it? This is what it means. You're having one solution, two solution. That means you're having two real solutions. That's it. Because whenever you have f of x, f of a equals 0, that's a solution point. Let's look into the previous problem. They are told this is not equal to 0. So you're never having a solution. But here there are two zeros and two separate values. The graph is something like this. It can be anything. It will be two real roots. It can be irrational or rational. We don't know because they have not given the discriminant. But we know it's two real zeros. That's it. Now, discriminant is less than 0 is imaginary. We have seen this already. It will not touch imaginary in the sense it's complex. Sorry, I tell imaginary, it's one and the same because when you solve these, you'll get two imaginary roots with imaginary numbers. Okay? Complex because a complex number is a number with real and imaginary part. When I tell imaginary, I'm meaning to say it's complex only. Okay? It's a complex root because it doesn't touch the x-axis. And it's always, discriminant is always less than 0. Now, a and b are both solutions and can be represented as fractions. Now, this is important. Whenever you can write, both have solutions, okay? They both have solution. But it can be represented as fractions. So, this may be 2 minus 2. This might be 3.5, 3.5. fraction or half, root half. These are all rational, right? Whichever number that can be written as fraction is a rational number. So you can have two rational roots. Two rational roots is the answer. Fraction means it's rational numbers. What are fractions? Half, one fourth, quarter, anything which can be written as a rational number. Now, here there are instances. Now, in such cases, you know what? The discriminant will always be a perfect square. But when it is not a perfect square, it will be irrational. Like pi value, 3.1415 keeps on going. That's irrational number. So difference between that, two rational roots. And over here we have another problem. See, what they have told is, this has one solution. This is important. They have given this equation. This is equal to 0. We need to solve. They have told it's one solution. So what is the thing? Here, what is the a value? A is equal to 1. B is equal to 1. The constant is m plus 1. Now we will do, the square root function. Sorry, not the square root. What I'm trying to say is discriminant. I just forgot the word for some time. Now discriminant is b square minus 4ac. Substitute the values. It's 1 square minus 4 multiplied by a is 1 and c is m plus 1. Here, this is an important thing. We know that one solution means it must be equal to 0. Only then you will have one solution. That means the graph only touches at one point like this. Now let's solve. I'm not sure whether it's correct. This might be 1. I'm not sure whether this is the correct answer. But anyways, it's something like this. Only 1. Now we'll equate this to 0 and solve. It is 1 minus 4m. Let's multiply this. Wait, 4m plus 1 equals 0. I'll take this 1 to the other side. It'll be, no, let's simplify first. Multiply 4 inside, it'll be 4m minus 4 equals 0. It'll be minus 4m minus 3. Okay, because minus 4 plus 1 is 3 equals 0. I'll take this 4m to the other side. It'll be minus 3 equals positive 4m. Take 4 to the other side. Negative 3/4 equals m. So this is wrong graph. It'll be something like this at negative 3/4 over here. And it goes up. Okay, this is minus 3/4 or it's 0.75. This is the answer. So m value, you don't need to graph. You just have to find the m value. That is negative 0.75 or negative 3/4. It's the same thing. That's how we solve it. And here describe three different ways to solve this. Now, okay, solve this in such that you have to find the zeros. Okay, how do you solve it? You know, one way is calculator method, right? That is factors method. Let's use a calculator and check. Here you have to just press mod 5 and 3 and then substitute 1, minus 2 and minus 15. The answer is 5 and minus 3. That's the answer. Okay, now when you factor it out, you have to write it like this. What is the answer? We got x is equal to minus 3, x is equal to plus 5. When you write as factor, you cannot use calculator method. So write this question as it is. It's written, original equation. Then we write factors. Whatever answer you get, take it inside. It will be plus 3, x minus 5. Now the answer is x is equal to minus 3, x is equal to plus 5. Because the fraction method, the factor method actually is, you have to multiply these a and c. What is the answer? It's minus 15. And b must be written down, minus 2. You must find two numbers such that when you multiply them, this is the answer. When you add them, this is the answer. So think over here. 5 multiplied by minus 3 is negative 15. 5 plus minus 3 is minus 2. Oh, sorry, it is minus and plus over here. These are the factors. Whatever you get over here, these numbers will be the factors. You can see it is x plus 3, x minus 5. This is the factoring method. But in calculator, it will directly give you the answer. Now, which do you prefer? Now, this is the one which you should prefer because this is the easiest of all. Now, there is one more method that is completing the square. It's fine, you can do it, but it's just a difficult method, I can say. But we have done completing the square in the previous questions. Please go back if you want. I'll just tell you quickly. Here we have, there must be no coefficient over here. Write this first term as x only. Next term minus, instead of 2, put it as 1 and then write whole square. And you must subtract over here with whatever this number is there, subtract it square of that. 1 square minus 15 equals 0. Now, this is also simple. X minus sign. If it was plus, it will be plus. Whatever is over here, you should take half of it. 2 becomes 1. If it was, say, x square minus 8x plus 15, it would be x minus 4. 8 by 2 is 4. If it was plus, it would be like this, the whole square. And then what you should do, minus, no matter what. If it is plus or minus here, doesn't matter. This only will be minus 4 square. Then write this last term 15. This is the thing. Okay, that's the completing the square. Now here, what you do is, we have got this much. So here let's do x minus 1 the whole square. Minus 1 square is 1 itself. 1 minus 15 is minus 16 equals 0. Take this to the other side. X minus 1 the whole square equals 16. X minus 1 square root on both the side. Okay, it is equal to square root of 16 is 4. Take minus 1 to the other side, it will be 4 plus 1. X is equal to 5. Sorry, I have missed one important thing. It is plus or minus 4 here. Okay, one answer is 5. Now take this. I have assumed plus 4. Now there is one more step. What if it was minus 4? X is equal to minus 4 plus 1. X will be equal to minus 3. These are the two answers. Sorry, I forgot this plus or minus, because whenever you have square root, it can be plus or minus. So this is the method. That is by completing the square. If you do two methods, it's enough, I guess, if you're writing. These two are okay. Now, you know the factoring, the quadratic formula method. This is one more. Or you can just write the three methods and solve it by factoring method and tell this is the easiest of all. The quadratic formula is given over here. Minus b plus or minus square root b square minus 4ac. This is the discriminant divided by 2a. You need to substitute all the values, whatever are there, and solve it up. Here also, remember there are two cases. What are the two cases? 2 by 2 plus 8 over here. In the numerator, it's plus 8. And 2 minus 8 by 2. It will be 10 by 2 or 6 by 2. It is minus 6 by 2, sorry. 5 minus 3. These are the two answers. That's how we solve it. That's the end. See, these are reasoning questions. They are not straightforward. They're not direct. So please try to understand the concept behind the problem and then try to solve it. And please do practice more problems. And this is how you can be thorough in this topic. Question number 17 is to divide polynomials by using the long division method. Let's look into the problems over here. Some of them are tricky. It's all real world problems. The first one is about averages. Bina has a list of n plus 1 numbers. Okay, and she needs to find their average. Two of the numbers are given as n cube and 2. So she has n plus 1 numbers. We don't know what that is, but these two are the numbers in that. Each of the other number, each of the other n minus 1 number are equal to 1. See now, n minus 1 numbers. So n plus 1, sorry. So one number is given, another number is given. And the rest are so many numbers. So if at all you imagine there is 6 numbers, okay? N is 6. So there are 6 plus 1. How many? 7 total numbers. They have told us 2 numbers, okay? And n minus 1 is what? 6 minus 1. The remaining 5 numbers are all equal to 1. Okay, they are 1, 1, 1, 1. We need to find average. So average means what exactly? Now if this is 6, 6 cube is 216. So 216 plus 2 plus 1 plus 1 and divided by 7, right? All the total numbers. Instead of this example, I will just give you another easy example. Imagine I have number 8, 2, 1, 1, 1. Just for understanding's sake. I need to find the average of these. What do? I will add them all up. I will add these numbers and divide it by the total number 1, 2, 3, 4, 5. This is the average. But here we don't know this n. We can't just guess any number. But we know one number is n cube, one more is 2, and all the other numbers, all the n minus 1 numbers, this can be 5 remaining numbers are all 1, or 6 numbers or 7 numbers. We don't know how many remaining, but they are all equal to 1. So what we can write is they're all 1, but how many numbers are there, remaining numbers? N minus 1 multiplied by 1. So if there are 5 remaining numbers, it will be 5 times 1. So it's 5 into 1. 5, 1, 1, 1, 1. You have to plus them. So this is the reason why we write it like this. Now divided by what are the total numbers? Total numbers are n plus 1. This is the main equation to write. Once you write this, then you can solve it up. N cube as it is plus here 2 plus n minus 1 divided by n plus 1. The denominator remains. Now when you simplify this further, you will get n cube. I'll write plus n, and lastly plus 1 divided by n plus 1. Now we can simplify this. How we can find, we can do long division method. Now here in this particular question, they have not done they have done synthetic division over here. See, now you can see this n cube plus 0 n square. N square is not there, so n plus 1 divided by n plus 1. If you divide, they have done synthetic division. That is fine. We have to just find the quotient over here. That is the average, right? If you divide these both, you get the average. This is the answer. But how exactly you do is, I will talk about synthetic division in the question number 18. So I will do long division over here because they mentioned long division. So what we do is, this dividend, we write it inside. I will just erase the left side. I hope this is clear. So now I'll erase all this over here. And you're remaining with the dividend n cube plus, there is no n squared. So it is 0 n square plus n plus 1 divided by, what is this? N plus 1. Now what do you have to multiply over here? What do you have to multiply to get n cube? So it is basically like this: n multiplied by dash, unknown number dash equals n cube. This is power 1. It should be n power 2, isn't it? So you multiply by n square. So you'll get n times n square is n cube. And this multiply over here. I hope you know this by now. This is simple, just long division. Change the symbols, signs, minus and minus. Cancels off. What is remaining here? 0 n square minus n will be minus n square only. Now next, bring this down. N comes down plus n. Now what do you have to multiply to n to get minus n squared? It will be minus n. Minus n will be minus n squared. So minus n will be written over here, and now multiply. It will be minus n squared minus, again n. 1 times n is n. Change the signs. It will just change to opposite sign. If they were different signs, plus and minus, it will be minus and plus. So this cancels. What happens over here? It will be plus 2n. Now bring this down. It will be plus 1. Now what do you have to multiply over here? Times dash is equal to 2n. Now you can't multiply anything. Oh yeah, you have to multiply. You have to multiply 2. I meant not any n, only the constant. Okay, only 2 times n is the answer. So it's plus 2. You will get 2n plus 2, and the remainder over here will be minus 1. So this is the answer. Now whichever method you do, ultimate answer will be the same: n square minus n plus 2, and this minus 1 remainder, always remember. I will write out to write this. I'll just erase this part here, and I will write the remainder. It's very important to write the remainder like that only. The answer, the average over here, is by long division n square minus n plus 2. But this remainder is also a part of answer. So you write minus 1 divided by the divisor n plus 1. Always by the divisor. Whatever the divisor is, whatever is remainder over here, if it's x or 1 or 2, write it over here and divide by the divisor. That's the answer. That's the final answer. Okay. So that's how we do it. We will look into this long division in a while. Long division only can be used when there is no coefficient over here. It should be only 1, only like this. Okay. N plus something. Then we can use long division. It's synthetic division. Very, very easy it is. Now the next problem here. The volume of a cylinder is given by pi into this term. If the height of the cylinder is so much, find the area of its base in terms of x and pi. Now, what is the area formula in terms of volume and height? See, I will write area into height is equal to volume. We know this is the formula, right? Now we know the volume, we know the height, we need the area. Take the h to the other side, it will be v divided by h is equal to area. This is the concept. So basically divide this by this. Just now we have done it the same concept. You can see this entire term divided by this term. What would happen now? They have again used synthetic division. So I'll just tell you how synthetic division is done. First thing, this term is there, right? X plus 40, make it equal to 0. What is x equal to? Minus 40. This is the first thing you have to do. That is the divisor here, minus 40. These terms over here, see now pi is removed out common, let it be outside only, at the end we can multiply. Now this over here, write the coefficients. What is the coefficient here? Nothing means 1. What is the coefficient over here? 32. Minus 304. Last one 640. These are the coefficients. Now the first term, no matter what, comes down itself, like this only, it will be 1. Now what you have to do is, I always remember like this. Now my name is Justin, so I just remember this. Why I remember this? Because from a long time, when I first studied this, I was always remembering this one. Okay, it's like a plus sign and this will be joined. How I remember is how I write my name, my signature, something like that, and I remember this signature part of mine. Why I'm telling you, this number comes down, this number is multiplied here and written over here. See, it's kind of like that, isn't it? This number comes down, multiplied over here, and write it over here. So this is the symbol, okay? Now I will just remove all that. Here, this 1 comes down, multiply this 1 over here with minus 40. What's the answer? Negative 40 itself, right? I will do the markings over here. And after multiplying, you write it over here. So this will be minus 40. Now what you do is you add these two terms, add them and write. What is minus 40 plus 32? It will be minus 8. Now again multiply this with 40. Now 8 4s are 32. It will be minus minus positive 32 and 0 is there. Add this up. What happens when you add it up? It will be 16. 20 minus 4 is 16. Now this multiplied by 40. Okay, 16 times 4 is 32, 64 minus 64 and 0. Add it up, 0. This is it. You're continuing the same procedure. This comes like this all the time till the end. Now this last term is always the remainder and this is the quotient. Now what happens is, this is the constant term. Now always what you start with, you started with x cube, right? The quotient will be 1 degree less all the time. Here this is x square, x and constant c. Now when you're writing this, it is x square. What is the coefficient of x square? 1. We don't write it. Minus 8x and lastly plus 16. This is the answer. There is no remainder. So this is the answer. But don't forget the pi which is multiplied outside. So this will be the final answer over here. Pi into x square minus 8x plus 16. They told it right in terms of x and pi. It's in terms of x and pi outside. This is the answer. That is the synthetic division. That is what we will do in question number 18. But since over here they have mentioned it, do it. Because long division just takes a long time. This is the synthetic division. Now then over here they are told to rewrite. Now the same concept. This has to be done in long division because look at the problem. It's 2x plus 4. So you have to do the long division over here. Each step is mentioned. And then write the final answer. Now what is the remainder? See, they have written write the remainder divided by divisor. The remainder is 0. 0 divided by anything is 0. So we don't write anything here. Only this answer. See, only this answer is written. Okay. What is the remainder? They have just asked the remainder. Remainder is 0. And this is the quotient. That's the answer. And same concepts over here. The long division. Now they have done a bit of long division. But we don't know the answers. So we have to trace back. Now we can see the first term over here is 3x. What has been multiplied? How do you understand? Now it is some unknown number multiplied with 3x. That will give you 9x square. What is that number? You can just divide 9x square by this. It will be 3. 3 times 3 is 9x. Here it will be 3x first term. Okay, 3x multiplied by 3x will be give 9x squared. And what do you have to multiply here? Okay, both are unknowns. So this is a bit tricky. Wait, let's come to it in a while. This is unknown multiplied with unknown. This is equal to 3x. So it's not enough information over here. There are two unknowns. Okay. Now, oh, I'm so sorry. I just confused myself. This is the unknown multiplied with this. I am so sorry. We are always looking at the first term only. This multiplied the first term right over here. The second term multiplied by the first term itself. So some unknown number multiplied by 3x will give us 3x here. So it's 1, isn't it? It should be plus 1. So 3x plus 1. If you have 3x plus 1, multiply 3x, it will be 9x squared. Multiply this, it will be 3x. That's the thing. Now, when you solve this, now what is, okay, we have traced the quotient, that's fine. We don't know this dividend, right? How do we do that? Now, look over here. We are basically adding these both up. Adding these both, but the sign changes here, okay? Adding these both up, the sign changes, and the answer is this. So you're basically adding some unknown number to what? To minus 3x. That will be equal to minus 3x. This cancels, it's 0. It should be 0 minus so much because they both are equal. So over here it will be 0, 0 plus. Okay. And then now some number was there that is brought down. What is that number? It is 5. It should be 5 over here, isn't it? It will be plus 5. That is directly brought down. So this is the thing. Now what next number would you multiply to continue this method? You have to just multiply by minus 1 because 3x times minus 1 is over here, and 3x times minus 1 will be minus 3x. 1 times minus 1 will be minus 1. Now change the signs. You will get this 0, and over here you will be plus sign, so it will be 6 plus 6. So that will be the answer. You can see. Okay, they have not done this last step, but anyways, if you do also, you will get this. Oh, I'm so sorry, I forgot one thing. All the things are correct. 0x, when you multiply anything with 0, it's 0 only, understood. But since you know after x square comes x, so let's write 0x, then other things is there. But they have not continued it, so I don't think so that is required. But if you want to continue, you can do that, okay? The divisor is over here. That's the answer. Now over here again you need to divide this long division method. Please do this. The divisor, the remainder is 6. So you write 6 divided by the divisor over here. This is the final answer. And what else over here again? See, please make sure. Okay, what did they ask? Check your work. Okay, you need to check about this. So how would you do it? Basically, if you start multiplying all this, you will get the question only, but that's just a onerous task. Most probably they'll just ask you divisor. Now we are identify this qx is quotient, rx is remainder, g of x is divisor. That's it. Now again you can check this. See, now I'll just give you an example. In numbers, if I give you an example, it will be much easier to understand. If you have 80 divided by let's take a smaller number so it'll be much easier. 21 divided by 4. What's the answer? It'll be 5 times 20 and your remainder is 1, isn't it? Now how do you write this? You can write this as 5 plus 1 by 4. That is 5 and a quarter. It's basically 5.25 the answer is, right? If you put in the calculator. So this is correct answer. Now, how would you get back? How would you check this? To check this, I have to just multiply this 5.25 with this 4. And this must give me 21. This is basically what you're doing over here also, okay? So multiply this entire term with this divisor. You must get what? You must get 21. So I'll just multiply over here because this is about rationals, right? So what happens over here? Multiply this 4 inside. 4 times 5 is 20 plus 4 by 4. It will be 20 plus 1, that is 21. And yes, that was the dividend. So that is correct. This is the check, basically, original dividend. That's the thing. Multiplying. You first multiply and then add the divisor. That's also the same thing, okay? After you multiply, just add the remainder, sorry. Now, another way is, what is this? 4 times 5, and then you add this 1 up. That's the answer. Now again over here, same thing, guys. Oh, I'm sorry. I just realized over here they have told polynomial is divided by this, and the answer is given and the remainder is given. So it is basically some unknown value. Okay, I'll write a, you divide it by 4x minus 6. The answer, the quotient is given as 2x squared plus x plus 1, and finally the remainder is minus 4. How would you check? Multiply these two first. It'll be 2x squared plus x plus 1 multiplied by 4x minus 6. When you multiply this, distributive property, let's take this from here. It'll be 4 into 2, 8x cube plus 4x squared plus 4x minus 6 times 2 is 12x squared minus 6x minus 6. Now simplify this, 8x cube, 8x cube, then what is over here? Minus 8x squared, and lastly we have minus 2x, and over here it is minus 6. Now add the remainder, minus 4. The answer will be 8x cubed minus 8x squared minus 2x minus 6 minus 6 minus 4 will be minus 10. This is the final answer. Just multiply the divisor and the quotient and then add up the remainder. So are we getting the same answer? Yes, that's the correct answer. 8x cubed minus 8x squared minus 2x minus 10 after adding the remainder. That's it. And over here, the last problem, this is the 36th problem. Luciana has a square garden. A new garden will have the same width and length, that is 3 feet more than twice the width of the original garden. Okay. Now this is the garden, right? We don't know the value of this original garden. It's a square like x and x or anything, L and L, anything. Now the original garden will be this much. The new garden will be 3 feet more than twice the width. Now width is x, 2x plus 3. This is what you're getting. Okay. Now, how would you basically find, this side is same, only the width is changed. Okay, the length is same width and the length, that is, so sorry, width is same, only length changes to 2x plus 3. Now, what is the thing? Define the variable, copy the diagrams, label. Okay, this is what we have done. The A, just write the diagrams and label the sides. Write a ratio to represent the percent increase in area of the garden. Use the polynomial division to simplify the expression. So percent increase is basically the new value minus the original value, divided by the original, always division by original. Okay, this is the percent increase because we're finding the increase, right? How much is increase, multiplied by 100 to get his percentage. This is the formula. Write a ratio to represent the percent increase of the garden. Use polynomial division. Okay, what you're basically doing is, let's write what is the new area. So multiply these two. The original area was x squared. What is new area? Multiply 2x into x squared plus 3x. So let's write it in the formula over here. New area is 2x squared plus 3x minus x squared divided by x squared into 100. Now this can be simplified further. I'll just write it up. This will be what? It will be x squared plus 3x divided by x squared multiplied by 100 is there. But this also can be simplified. How? Distributive property. This is x squared by x squared plus 3x by x squared. Let's just go to a blank spot. Okay, this is blank. Over here, you're doing this, and then what is there? It will be 1 because x squared by x squared plus 3 by x, the whole times 100. That is the variable equation for the second problem. What was the second problem? This is the percentage increase in the area. Now they are telling if the original garden was 12 foot square, find the answer. Okay, if this was 12, x was 12, just use the calculator over here, guys. We will take a calculator and solve. Here all you need to do is 1 plus 3 by 12, whole thing, put brackets, multiply it with 100. So it's 125. So percent increase from this old to the new one is how much we got? 125. I just now had the memory of a goldfish because I just forgot what was the number. It's 125%. Okay, it's percentage. Let's just check the answers. Over here, let me just remove this. We get XX. This is what we had written. And then you can solve over here. See, we have to just solve this up. And wait a minute. Okay, this is the answer. 1.25 or 125%. Okay, they have, let me just go back. Now here they have written percentage change. Basically, see, the increase means, let me just see over here. They have told percent increase for both the times. The area of the new design would be percent. Okay, really, see, there are two formulas. One formula is percent change. That's what I think. We call it like new value divided by the original value multiplied by 100. This is change. That's how what's changing. It's 225% change. But increase means you must find the original value. We found the original value, right? New minus the original. This is the difference in both divided by the original into 100. Okay. So I remember long back, not now exactly, but much long back, for one of the maybe 1 year ago or something, I was trying to figure out this, but I don't exactly remember. There's a difference between these two. One is maybe percent change or something, one is percent increase. See, over here, you can find the increase or decrease, and this particular formula can be positive or negative. This 125 means here it's something, right? More than this by 125%. That is what they are telling. Okay, more than this extra 125. Whereas this one is telling the total percentage change of this. This entire thing is 225. Okay, see, now if this is 100, this much is 100, right? Now 125 is the increase in the new figure. See, this is the 125. If this is 100, this is 100, and this is 125, the increase. That is percent increase. See, over here it's mentioned. But what is the change exactly? Change is basically entire thing. That is 100 plus 125 is 225. That is what it is. But here they have given the same heading, but just understand this is the difference. So make sure you write it like this. Show it in the figure like this. Then I'm sure you'll get full marks no matter what. So that is the thing. And that's the end of this particular lesson, of a particular question. I hope this is clear. It's more of reasoning problems. So understand the question thoroughly and then go to solve the problems. The question number 18 is about synthetic substitution. Before we begin this, please make sure you watch the previous video, that is question number 17. Because from that video, in that video, we have already done synthetic division, synthetic substitution. Now we will learn more about this topic here. Here they have asked to construct arguments. Divide the polynomial function fx cubed minus 10x plus 8 by the factor x plus 5. State and confirm the remainder theorem of this particular function. We will come to this in a while, but first let's divide this. Now, since they have told synthetic division, first you must see whether there is any factor over here, a coefficient. There is nothing. Then we can use this. Here, whatever is given to you to divide, this is the divisor, isn't it? X plus 5. Make it equal to 0, x is equal to minus 5. So this is very important, x minus 5. Looking at this, just change the sign, minus 5, write it like this. What is the other terms? Here we have 4x cubed. There is no x squared, so it's 0x squared minus 10x plus 8. And now let's substitute. 4, first term, 0, next term, minus 10, and lastly 8. Now, the thing is, you must always remember something like this. What is that for? Here, it comes down as it is 4. Multiply with minus 5, it will be 20. 4 times minus 5 is minus 20, sorry. Now, add this up and write it down again. Minus 20 over here. Minus 20 times 5 is positive 100. Add this up, it will be 90. And now multiply 90 times 5. 9 5s are 45. It will be minus 450. And what happens when you subtract? It will be minus 442. Now the last term here, this is the remainder. And you always will have constant term over here. This is constant. This is with the coefficient, the variable of x and x square. Another way to check is it, check it is just see the dividend. It's x cubed, so it must be quotient will be 1 less than that. That's it. So this is the answer. Now we can check our answers. Over here, you got minus 442, same answer. Now, what else did they ask? From the remainder theorem, okay, this is about remainder theorem. This is a remainder theorem that states this, what we got remainder can be easily obtained if you substitute this number over here. What it means is, now we got this, right? The remainder is negative 442. We need to confirm, means check the answer. So directly substitute this part. X is equal to minus 5. Remember, it's not 5, it's minus 5, okay? Substitute minus 5 here. F of minus 5. Instead of x everywhere, it will be minus 5 the whole cube minus 10 into minus 5 plus 8. You can use the calculator and substitute directly, or you know it is 5 cube is 125, minus will be minus 500. 125 into 4 is 500, minus 500, minus. Now, whenever it's square, it will become positive, but if it's odd numbers, negative remains, sustains or remains. Minus times minus will be plus 50, and lastly, what we got, plus 8. It will be minus 450 plus 8, that is equal to negative 442, and that is what the remainder we got, and that is the answer even over here by checking. So this is what the remainder theorem means. Now that's the answer. We have confirmed it over here from the remainder theorem by substitution. Same thing. Okay, now this is a reasoning problem. The polynomial function p of x is symmetric in the y-axis. Okay, let's do a simple thing. I will assume this to be, it's symmetrical along y-axis. This must be a, quadratic, something like this. I will just draw a graph like this. Okay, that is not at all symmetric. Symmetric along y-axis means it will be like this, and it's symmetrical. Okay, equal shape. And contains the point 2, minus 5. Okay, my bad. Whatever I did is wrong. I'll do something like this, okay? Now, I'm not sure about this, but it might be like this itself. But anyways, this is more convenient. Anyways, 2. Imagine this is 2. X is 2, and it'll be minus 5 here, okay? This is minus 5. This point is there. 2 and minus 5. What is the remainder p of x when it's divided by x plus 2? Explain your reasoning. Okay. What is the x value over here? Minus 2, right? Now we know 2 minus 5 point is there, and it's symmetrical along y-axis. So the same point must be there at minus 2 when it's reflected. See, it's symmetrical. So reflection along y-axis over here will be minus 2, minus 5. This point must exist, isn't it? It will be minus 2 and minus 5. This one. This and over here. So what you're basically telling is, when you do this, when you divide a particular equation, you will get the remainder of negative 5. That's what we can say. Let's look into the answer. See, it's symmetric along y-axis, so it must contain this point. According to the remainder theorem, the polynomial x minus r is p of r when you substitute in the equation, okay? And the remainder, basically when you substitute this r value in the equation, you must get the remainder of negative 5. Because we know over here it's negative 5 and symmetrical along y-axis, so this graph is important. If you draw this graph, I'm sure you'll get full marks. So just draw this graph, it explains more. Because over here, this graph, it shows we already have this point. So it's symmetric on y-axis, so there must be minus 5, minus 2, minus 5 as well. So the remainder is what? Minus 5 here. That's the answer. And over here, see, this is a very straightforward problem. What we just did, on problem number 56. So please do this by yourself. It's just synthetic division. Over here, you have to use root 3, same thing. Don't worry about anything. It's 1 comes over here, multiply. It's like this. Add 3 plus root 3, again multiply right over here, and then simplify it. That's it. Now, yeah, this is multiplied by root 3. Yeah, that's it. See, now if you're thinking what happened over here, I'll just make it clear, because I just got a bit confused. You're multiplying this over here and then writing it over here, right? 3 plus root 3 multiplied by root 3. What happens? 3 root 3 plus 3 over here, isn't it? Because 3 root 3 is 3, 3 root 3. So that's why we get this. And add the real numbers together. 5 plus 3 is 8. And now you can verify by substitution. Substitute root 3 over here. You must get this answer. If you substitute, you will get it. In your calculator, you might get decimal point. It's fine. Just check this and this will be same no matter what. And now the last problem here. If x plus 6 is a factor of this term, determine the value of k, factor of polynomial, and confirm the result graphically. Now what they are saying is this is a factor of this. So doesn't matter, just do synthetic division, direct synthetic division, but keep this as it is like k. And since they have told is a factor, what does this mean? Factor means doesn't matter what, this remainder will be equal to 0. That is the concept. Because now if you have x plus 1 the whole square, it is x squared plus 2x plus 1, right? Yeah. Now here I can tell x plus 1 is a factor of x squared plus 2x plus 1. Why? Because when I divide this by x plus 1, you can try this later on, the remainder will be 0. Your quotient will be x plus 1, but the remainder will be 0. Whenever there are factors, the remainder is 0. That's the rule. So here x equals minus 6. When you solve like this, whatever the remainder, it must be 0. But we don't know this first part. So now we got the remainder to be 432 minus 216k. That means equate that equal to 0 and now solve. Take this 216 to the other side. It will be 432 equals positive 216k. K will be equal to 432 by 216. And the answer is 2 equals k. This is the answer. Now this is the answer for k, okay? Because the remainder must be 0 and solve it, you got it. Now substitute back over here. Substitute k over here. You can then solve the other factors. Oh, sorry, one second. Don't substitute back over here. That is the question, right? What way do we need to substitute? Over here we need to substitute k. Because the remainder is 0. Now k value is 2. That means it's 2. 15 minus 6 times 2. Minus 77 plus 36 times 2. Okay. Now find what is the, okay, over here this is constant value. Over here you should multiply by x. Over here it will be x squared. So the answer will be 2x squared plus, because this 15 times minus 12, it will be 3x. And now this you need to put in the calculator. Wait, it's 72 minus 77. It is negative 5. This is the answer. This is the quotient. Because we found the k value, substitute back over here, you will get the quotient. Let's just check the answer. Is that the quotient? Yes, that is the quotient. Okay. Oh, now 1 second over here. I forgot to write it. It's 15 minus 12. It's plus 3x. Okay. My bad. I wrote it wrong. This is plus 3x. Now again you can divide it further. But no, sorry. You can't divide it again because you don't know the other factors. Use the calculator and find the factors. Don't go to do the quadratic formula or anything. Just take out your calculator. We will use mod phi 3 and put the quadratics over here. It is 2, 3, and lastly we have minus 5. And what is the answer? 1 and minus 5 by 2. I'll tell you how to write this minus 5 by 2. X is equal to 1 is simple. X minus 1 will be the factor. What about x equals negative 5 by 2? Answer is this. But when you write factor, take the 2 to the other side. It will be 2x equals minus 5. Take minus 5 to the other side. It will be 2x plus 5. That is the factor. Or there is one more way. X, take this entire thing to the other side. It will be plus 5 by 2 equals 0. Now multiply throughout by 2. It will be 2x plus multiply. See, it's like this 2. It will be here 2x, 2 and 2 cancels, you will remain with 5. The factor will be 2x plus 5. Any method you do, you will get that answer. 2x plus 5 and x minus 1. So that is the factor. Now if you want to find the solutions, just see over here x is equal to 1. Then over here we had x is equal to minus 6. And what is negative 5 by 2? It is negative 2.5. These are the factors. So that's the thing. Now, since we have three solutions, what happens here? This is a cubic graph. In the sense, it is a cubic graph, and you can see the k value was positive 2. That means the how is the cubic graph? Positive is something like this, right? You will have 1, 2, and 3 solutions, and this is going towards infinity as x tends to positive infinity. Wait a minute, what is happening? I'll write the over here the end behaviors as x tends to positive infinity. The y value or f of x value must be positive infinity. This is tending to positive infinity. Whereas as x to negative infinity, this side minus infinity, f of x or y value also will be negative infinity. This is the cubic graph. So this is the end behavior they have written. And that's it. That's the answer. You can just draw a brief graph. You don't need to draw exact graph. Here you can see this. They have told graphically. That's why I drew the graph. This is somewhat the graph. But here this is not accurate at all. Why? Because it should not pass by 0. There is no solution of 0. One solution must be this. I'll just erase this one. Let me draw some line over here. This must be minus 6, minus 2.5, and lastly 1. Okay, these are the solution. Just draw some cubic graph, positive. So right side goes up, left side goes down. That's it. You can write the end behavior then. So that's it. Please make sure you understand the reasoning problems well. Understand the question, reason it thoroughly, and then try to solve the problem. The question number 19 is to graph and analyze cube root functions. It's not only cube root, there is square root as well. Now here they have given a graph already. The graph is given q of x. This is q of x graph shown, and examine this particular graph. Now you don't need to do accurate stuff, but how exactly do you graph this? You know, this is a square root. If you have the basic knowledge of square root, it's always going to go up like this. But you can see this minus 3, so it's going to go down. So basic things. And now since it's x plus 2, here now if this is the x-axis, plus 2 means it will go left side by 2 units over here. And this minus 3 will change its amplitude. Now then, but exact graph, if you want, you can easily do it in calculator from the table. You'll get the values and then graph it up. So since it's writing, I would highly suggest that, because you'll get a table, just copy the values and you will get the graph. But how would you start? The first is the starting point, because square root has a particular domain. It's not all x values. Now you must look what is inside the square root. X plus 2 must always be greater than and equal to 0. It's not only greater than, x plus 2 greater than 0, wrong. It must be greater than or equal to, because in square root even this value is included. Okay, 0 is also included. I mean, inside square root you can even put 0, you will get an answer. You can test it. So what happens over here? X greater than or equal to 2, take this 2 to the greater than or equal to, instead of 0, take this plus 2 to the other side, will be minus 2. So any values from minus 2 to greater value is possible over here. So this is the concept. Now here what we can do is simply just you take a calculator and I'll show you how to solve. So what you do is mode, table is 7, and now this function, put this function as it is, minus 3 square root alpha x plus 2. And g of x is not this, so ignore that. And starting where it should start at minus 2. This is very important. That's the reason why we are doing this. Okay, starts at minus 2. Let's take a value, say n phi. Okay, it's fine. Let's take one step. That means all values from minus 2, minus 1 will be there. If you put step of 0.5, you will get minus 2, minus 1.5, 0.5, all those, every 0.5 interval. Now you got a table, right? For writing exam, you can just draw this table quickly. X, f of x, or p of x over here. Substitute the values of x, minus 2, minus 1, 0, 1, 2, 3, 4, 5. And look over here. These are the x values. These are the y values, sorry. Now here, the table of values. 0, 3, negative 4.24. All the same values we have got. But we have got more over here. And now with this, you can easily graph, isn't it? Now what you do? You have to graph it. How do you graph it? Basically, you start from minus 2. Minus 2 will be 0. If you put minus 2 here, it will be 0. And next, minus 1 is how much? Minus 3 minus 1 will be minus 3. That's the amplitude over here. And then it keeps on going. Just a rough curve. This is it. Now, that is the first part. This is it. But you need to compare as well. Now, what do you have to compare is these features. I'll tell you a few of the features. Let's see both the graphs together and I'll tell you now. What is the domain? Domain for square root function or any positive 2, 4, 6, 8 is whatever you solve over here, whatever is inside that must be greater than or equal to 0. Then you get the domain. So here the domain is all possible values greater than or equal to minus 2. That means minus 2 is included, comma, positive infinity. This is the domain. What is the range? Range is all possible. Since it's minus, it is all possible values, all negative real numbers. That is from 0, 0 is included, till minus infinity. This is the range. This is small bracket. Infinity is always by small bracket. Big bracket means this value is included. If it is only greater than 2, then we use small bracket for 2. That's not included. That's the thing. Now then, what do we do? Here, this is big bracket. Domain is done, range is done. This is for square root, okay? This one. Now over here we have the graph already for cube root, right? Cube root, it's so easy. The domain and range is all real numbers. All real numbers means it's always from minus infinity to infinity. You don't have to worry anything. Domain keeps on going, range also it keeps on extending. So that's the domain and range. What else you can check? You can see the intercept. What is the x-intercept here? X-intercept is minus 2. What is x-intercept here? Positive 2. What is y-intercept? Minus 3. Y-intercept is minus 3. Here it is somewhat negative 1.2 or something like that. Okay? Not accurate. And what else can you do? What is the end behaviors? Here, as x tends to minus infinity, this is minus infinity, right? As n takes to minus infinity, this will go towards, where is it going? It goes like this. It'll keep on going downwards, okay? The y value will be down, minus infinity itself. That's the thing. As x, see, I'll write it properly. As x tends to minus infinity, what is y value? Y value, it's downwards. So it is also minus infinity. As this positive x tends to positive infinity, y is also positive infinity. What about this? Here end behavior, as x tends to minus infinity and x tends to positive infinity. Let's do positive infinity first. Y value will be negative infinity itself. What about this? As it goes to negative infinity, the y value is 0. Here it stops, isn't it? So it is 0. So this is the concept here. And so let's just keep going over here. This is about it. Oh, what is happening? Decreasing or increasing? We saw that square root is decreasing, whereas this one is increasing. It's going upwards. So that's it. Then positive and negative over here, you can tell which parts is negative. Whenever x values are less than 2, it's negative. Greater than 2 is positive. Over here, whatever is greater than minus 2 is only negative. There is only negative part of this square root function. So these are some comparison. It's a very straightforward comparison. Nothing much in this. Same way over here. But I'll just tell you what is this equation. They have not given the equation, right? P of x, which is 2 less than the cube root function. Okay, what is cube root function? X, this. But 2 less than minus 2. Okay, this is the graph. Once, let's just check the answer. Yeah, that's the equation. Now you need to graph this one because the square root function is given. Same thing. You can just put this in calculator and graph, but here you can put any domain, anything. So put some values. This is just y. It just shifts. That doesn't matter. Put some values from minus 5 to plus 5, I guess, or over here minus 2 to plus 2. That's also fine. You will get something like this. Here minus 2 means the shifts downwards, okay? But you will directly get this table from the calculator and put it. Now you're telling the same thing. Domain is all real numbers. Over here it's only positive real numbers. Range and everything you have to just tell over here, okay? See this comparison, same thing. Same concept, same things. Here also it's the same concept. Over here you just have to graph this. Now both are square root functions. Here one is going to the right, one is going to the left. Doesn't matter, cube root, square root, whichever, you have to just compare them now. These are both root functions only, but it's square root. Because only square root will be starting from some point. There will be a restricted domain. Whereas cube root will have infinity to infinity, minus infinity to plus infinity. And compare the domain and range, just like what we had done a while ago. That's the end of this topic. Please be thorough with the domain and range. Try to use calculator table method. Write the table, then graph it, and then compare it easily. The 20th question is the last question in the EOT for the grade 10 elite. This is to solve exponential equations in one variable. Now here we have real world problems or reasoning problems as well. Now look at this problem. They have given us solve 16 to the power 18, 1, 2, 3, 4, 5 times and equal to 4 to the power x. How would you do this? Plenty of methods. You can take log, this, that and all. But the first thing is we need to differentiate certain things. Now if you have a to the power x multiplied by a to the power x, what happens? We do x plus x. The powers add up. But now if you have plus here, let me write it separately. Sorry. If you have a power x plus a power x, then it is not the same. Here what happens is, it will be a power x, it will be 2a power x. Now here we have 5 times 16 power 18. 5 times 16 power 18. This is the concept over here. That is equal to 4 to the power x. Now, how would you solve this? Here, you can simplify this and take the root and stuff. But there is a log method. This is a very easy problem if you take log, natural logarithm. Because these sort of problems, right, are so easy to solve in log. I will just see what is the method used over here. Okay, they have used the graphing calculator method, which is not available. And I don't think so in your calculator, this will be giving you any answer. So this much is correct, but then graphing calculator is used and done. But if you don't have graphing calculator, this is the easy method. What is the base of the exponential? See, this is exponential. X is there. The base is 4. Take log base 4 and whatever is the value here, 5 times 16 to the power 18, that is equal to log base 4x. Now you should just remember so much, because when you study log functions, you will learn a lot about this and you'll understand well. But now, as of now, just remember this. You can put this directly in calculator, but right side, what happens is whenever the base of the log is same and this is same, it is 1. And this, whatever is there, comes down. It will be x log base 4 and 4. It will be log base 4 and 4. This term is 1. Okay, because that is the rule of the logs. So for now, just remember, whenever you have x over here, take log on both the sides. Provided the base of the exponent is 4, take log base 4. And this is 1, so it will be x. This side, just put it in the calculator. Let's do it. I'll show you how to do it. All you need to do is press this symbol. Log base 4. 5 multiplied by 16 to the power 18. What is the answer? It is 37.16. That's the final answer. Yes, that's the correct answer. If you have graphing calculator, then you'll directly get the answer as well. But since you don't have, we can use this. If you don't have, sorry. What would be a more beneficial change to 5-year loan at 8% interest compounded monthly, reducing the term to 4 years, or reducing the interest rate to 6.5 for 5 years? Now, I hope you recall the compound interest formula. This is important. Let me just write it out over here. It is always y equals, you can write it in different ways. Principal amount multiplied by 1 plus r by n, the whole power nt. This is the formula. This is called the compound interest formula. This is used in banking generally, where, say for example, a company has taken a loan from the bank and they'll calculate interest and all that, how much payments should be done, all in this formula. Now we can see many things are given. This is important to understand. It's a 5-year loan. That means you will have 5 years to pay back the loan. Okay, but when you pay back for 5 years, wait, let's read over here. 8% interest compounded monthly, reducing the term to 4 years. But if you pay 8% interest every month, then it's compounded monthly, but the term is reduced for 4 years. In 4 years, you can take it off. But otherwise, you must pay at 6.5. If it's 5 years, it's 6.5%. But if you make it 8% interest, the term is only 4 years. So within 4 years, you will give back the money. So the interest is increased. As the years reduces, the interest increases. Now let's apply the formula in both the cases. Here, first one, the final answer would be principal amount is unknown. Let's keep it like that. 1 plus, what is R? R is the rate. I will do for 4 years first, okay? This is for 4 years. 1 plus R is 8%. Compounded monthly means n value is every month in a year. So it is 12 because every year it is compounded. So n is 12. The power 12 times t is how much? 4 years. Now if it is 5 years, the same formula, only thing is the p is unknown. It will be 1 plus the rate of interest changes, 6.5% divided by 12. And over here it is 12 times 5. Now let's put it in the calculator and see. Solve them in the calculator directly. Only P, leave it as it is, the remaining part. Here all you need to do is say, just put this up, 1 plus 8%, that is shift and this symbol over here. Sorry, shift and this symbol over here. Divided by 12, close the bracket, power 12 times 4. That's the first part. The answer is 1.375. You can just write it over here, 1.375. And I will do the other one also, and then I'll write it together. The years is 5, and we have over here 6.5. The answer is 1.382. See, let's just go to the answers. 375 and 382 times the principal. So now which is greater and which is smaller? If you pay for 5 years, it's going to be 1.38 times whatever the amount of principal. If it is 10,000, it will be 13,000 ultimately when you pay back after 5 years. Whereas, no, sorry, 13,800 something. Whereas if you take it for within 4 years, it will be 13,700. You're going to save a little bit. This is less than this. So reducing the term will be more beneficial because ultimately when you pay 4 years, it will be this multiplier. So it's lesser than the other one. That's the answer. That's it. Now another problem over here is about to determine the following statements are sometimes, always, or never true. Explain your reasoning. Now this can be solved in different ways. Let's see over here. You can see 2 to the power x is greater than minus 820x. Okay, for all values of x. How would you solve this is, for all values of x. Now, whenever you have exponent, anything, x can be any value. It can be negative, positive, 0 or anything. What happens? You will get a positive answer only. It will be more than 0 no matter what, because the exponential graph, sorry, that is a very bad line. Let me just draw a straight line. The exponential graph is like this. It's always positive. You'll never touch this axis. Why? It is 0 is an asymptote. So it's always range values. Y values are always greater than 0 no matter what. So here, for all values of x, this will be positive. This part here, 80, 20 to the power x, doesn't matter what, it will be positive itself. But there is a minus sign outside the exponent. So minus into plus is what? It will be minus. Plus will be always greater than negative sign. So it is always true here. So this will be always true. Why? Because 2 to the power x will be always positive. Here, this part will be positive. 8, 20 to the power x will always be positive. But this minus sign is there, so it will be negative, always negative. This part is always positive, but minus is multiplied, so it's always negative. So, yes, 2 to the power x will always be greater than this other term. Always true. Now, here we have about the graph of an exponential growth equation is increasing. See, what is this growth equation? Growth means this b value is always greater than x, right? So imagine you have this growth is something like this. The okay, that is exponential growth. Now, what is decay? Let's do this also. Decay is like this. It comes down, okay, like this. So this is the exponential graphs. If it is growth, it goes up. If it's decay, it's going down. The graph of an exponential growth is increasing. Yes, it's always increasing. Whereas the graph of exponential decay is not increasing, it's always decreasing. When this b value is less than 1, the graph is downwards. You can check it in Desmos. You can put y is equal to, say, 2 to the power x. And then that is a growth function, okay? Growth, g. Whereas if you put y is equal to 0.5 to the power x, this is decay, it will come like this. So this is always true. This, 1 minute. I thought of editing the previous part, but I'll keep it because it's a very important lesson because I just forgot this A term altogether. I was just thinking about growth and decay. That's it. But look here, there is an A term. Now, what happens? Because I was thinking it's like y is equal to 2x, that's it. But A is there. Now, if this A value is positive, yes, it's a growth like this. But what if A is negative 2x? This one decreases. It's like this. If this is the x-axis in the middle, always it will go up when it's positive, going down when it's negative. So it's sometimes true, yes, sometimes it will increase, but if a value is negative, it will always decrease. This is the concept. Now, even for the decay, it doesn't decrease always, it is increasing. Yes, it will increase as well. Now I'll tell you why. Because when now over here, when it's a decay, it will be like this, right? It will not touch, it will be exactly like this. It's going down, down, down. It will almost touch here. This is a decay function. This is decreasing. It's decreasing, it's not increasing. But if a value is negative, it's minus 0.5 to the power x, then what happens? It flips. It's like this and it keeps on going. It will keep on increasing. The graph increases. You can try this in Desmos. You can try y is equal to 0.5 to the power x. You know the basic understanding of decay is always downwards, but if you put minus, it will come like this. This is the reason both the problems, sometimes they are true, sometimes they are false. Yes, in certain conditions it will increase, but certain conditions it will decrease. Even over here, this will be sometimes true. That's the answer. Now write an exponential inequality with the solution of x is equal to exponential inequality. X is equal to less than or equal to 2. So what you can do is you can just take any power to anything, because it'll be the same. So you can just take e to the power x will be less than or equal to e to the power 2. Now, I mean, you must do the, let's just check the answer. You must do the operation on both the sides. Now over here, x, so, sorry, wait, let me just, I took e value, Euler's number. No, you can't take because e value is more than 2.2, it is 2.7 something. No, sorry, you can, doesn't matter. See, what you're doing is just take both the sides, take this two things to the power of both the sides. This is basically this. If you take 4 to the power x less than or equal to 4 square, the inequality will be maintained, okay? So it is just that this has a solution. That's it. You can use, but basis must be same. That's the only concept. I'll just tell you why. Because if you have, say, for example, 2 to the power x plus 3 less than 2 to the power 5. We have this power. As long as the bases are same, we can equate the powers, right? We can write it as x plus 3 less than 5. We know this concept. So same way, use same bases. Instead of this, you can even take 5 to the power x less than or equal to 5 to the power 2. This is also fine, okay? That's it. That's what I meant at the beginning. Take power on both the sides, right? That's the concept. And over here we have an exponential problem where we need to solve. Now, over here, to solve this problem, you need to know certain things. Whenever this particular problem comes, what I do is I always write certain numbers. 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. 3 to the power square, 3 to the power 3, 3 to the power 4, 3 to the power 5. Same way with 4 square, 4, 3. At least you should know 2 to 3 values. 2 to, like, till 4 to the power 4. Now I'll just write it over here. Why I'm writing this is you need to know this in your mind. 2 square is 4, 2 to the power 3 is 8, this is 16, this is 32. What about 3? It is 9, 27, 81, 243. Now here it's the same thing, 16, 64, and then you will get 216 and so on. Okay. 5 square is 2, 5 square is 25, 125, 625 and so on. Over here you will have 36, then you will have 600 and something, and it goes on. Okay. Now why I'm telling you this is, look here. Whenever you see these numbers, a set, they always will give you within this range. Okay, within this range, within this also range, not more than that. Now I know 27, 81, 3, 9 all can be written with the same base. This is the most important thing. Now if you know this much, then you can reduce all of them into the same base. Okay. Now what does this mean exactly? I will write 27 into, instead of 27, I'll write 3 power 3. And then I'll write the exponent what was originally there as a power. 3 to the power 4 is 81. Then write x plus 1. 3 as it is, base is same. 3 power 3 only. Okay. 2x plus 2. Multiplied by 3 square the whole power 4x plus 1. Now we can simplify. The powers, I will write something over here. If you have a, m to the power n, sorry, it is n, okay, or xy, you can take anything. And if you have a power m multiplied by a power n, the difference is over here, you multiply the powers. When power to power, it is a m times n. Whereas over here, you add up the powers m plus n. When the base, there are two bases. Now here what you do, you multiply the powers. In the sense, it will be 3 times 2 is 6x multiplied by 3. Now this 4 will be distributive property, okay? It's not just for one term, it's distributive. So it will be 4x plus 4 equals 3, 2x plus 2. And lastly, we have 3 again distributive property. It will be 8x plus 2. Now all the bases are same, so equate whatever is the power. 6x. Now, okay, one more thing. Before we equate it, I've just written this rule. When you have same base and you have two different powers, you add them up. 3, 6x plus 4x plus 4. That is equal to 3, 2x plus 2 plus 8x plus 2. Now let's simplify this. 3 over here, what is it? 6 plus 4 is 10x plus 4. And 3 over here, 2 plus 8 is 10x plus 4. Now this bases are same, so you can equate whatever is the power. 10x plus 4 equals 10x plus 4. And now over here, what you do is you simplify, take it to the other side. Now here, 4 cancels. Divide 10. And also x cancels, okay? It is basically 1 equals 1. It's an identity. All the time it's true. Both the sides are absolutely true. Because you're getting both the sides are same. So this is true, okay? Now see, we got the same thing. But here, they have simplified it further and just kept x equals x. Both the sides are same. That's it. And then we are in the last problem. If you are given the initial and final amounts of a radioactive substance, initial and final, and the amount of time that passes, how would you determine the rate at which the amount was increasing or decreasing in order to write an equation? Now, this is a formula. Okay, rate formula. It's given by y. Final amount is equal to the A initial amount times rate is given as r power the amount of time, r power t, I guess, okay, increasing or decreasing the time interval, yes, the amount of time that passes. So this is the equation. So over here, y is the final amount, okay, final value. A is always the initial, okay, initial. The r value is the rate, r is rate, r over here, and t is the time interval, time. Now here, if you have been given the initial, you have been given the initial, sorry, A and the final, A and Y is there with you of a radioactive substance, and the amount of time, the T is also given. How would you determine the rate at which the final amount was increasing or decreasing? So you need to find what? T, right? How would you find to determine the rate at which? Sorry, time is given. You need to find r. So let's solve for r. Sorry, this is also given. Only r is unknown. So first take the a and divide it, because this is an exponential function. It will be y divided by a equals r power t. Now take the square, not square root, root of this number. That's it. That is the answer. Now imagine you had been given, say, final amount is 10, initial amount was 5, and R is, say, rate is something unknown, but the time is, wait, let me make this as, yeah, let it be anyways. Let me make this 20, okay? So it's easier. And this one over here as square. So I'll first find 20 by 5 is 4 equals r square. Now I take square root on both the sides. This cancels. The answer is 2 equals r, right? This is what I'm doing. Now the root must be taken to this term. Let's just check the answer. Okay, they are telling divide the final amount by the initial amount. Yes, we did that. Divide this, just take it over here, right? A to the other side. You're dividing the final amount by initial amount. And then the n is the number of time interval that passes. They have taken this time t as n. That's fine. We have taken as t. Nth root. We have taken t time as t, right? The tth root. Or if they take it as n, nth root. Take the nth root. That's it. That's the correct answer what we got. It is square root t, the time interval, divided of y by a, where y is the final amount, a is the initial amount. This is how we can solve it. If you know this formula, this is a formula which is given for the rate. You might have come across this. That's the final amount into initial amount multiplied by the exponent. What is that exponent? Rate to the power time. That's it. That's the end. We have finally come to the end of all the EOT questions for the grade 11 elite. I'm sorry for the delay. There was a delay when I was uploading all because of certain unfortunate circumstances. But anyways, I hope you have some time at least to go through them. I hope as I was publishing them, you could have gone through them. And all the best, guys. I hope your exam will be easy. I hope you are prepared well. Take enough rest and make sure you are well refreshed before the exam. And take it easy. Make sure you recollect whatever you have learned and try your best in the exam. I hope everyone gets great marks. Take care and wish you all the best and happy learning.